one. Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have our student Girish doing his presentation for the course ROS Navigation in 5 days. So we offer some certificates for certain courses in our ROS learning platform, and one of them is to do autonomous navigation. And here Girish took a course on navigation and autonomous navigation, and then he's going to present us his final project, which is basically adding autonomous navigation to a real Turtlebot 3 robot. So, hi Girish, welcome back.
Hi Rodrigo, how are you?
I am great. Excited to see you again and what you have in store for us with your project here. So,
hmm
you know the drill. Whenever you're ready, you can share your screen with us so we can take a look at what you've done for navigation.
Sure. Before that, good afternoon to you and good day to all the viewers. All right, so let's get
All
started.
right.
I'm going to share my screen.
Okay.
All right, so now we'll be seeing our project, and I've already loaded the live capture of the real robot arena. So you have it on the top right,
Mm-hmm.
and the bottom it's a window to load RViz for you, and on the left side you see the terminals. So we basically have four terminals, which is one for RViz, one for Navstack, one for my programs, and one for teleop robot control.
Very
And
organized.
why I have this is because I don't want to use a joystick because it kind of alters the localization. So I want to be safer and not use that or joystick on-screen joystick.
Mm-hmm.
So
I
let's
see.
get started. So let's first start our RViz. It's gonna take a couple of minutes, few seconds probably.
Are you running? Oh yeah, you have an RViz config. Um, that's
Yes,
that's curious. It's taking so long.
I I have a configuration for all parts of the project put in. So
As
it's
you
not gonna
should.
show most of it. It's not going to show most of the thing for the first part, but all of them will get covered when the final part is being
Uh
shown.
huh.
So my project actually has three parts. The initial part is mapping. The second part is localization to save the spots on the map, and then the third part is to navigate to the saved spots using the ROS navigation stack. So initially, we're going to see how the robot maps the environment. So we're going to launch the mapper. So ROS launch my Turtlebot navigation init mapping. All right, so this launches the SLAM gmapping node, which is in the gmapping package of the ROS navigation stack.
Mm-hmm.
And once this loads, we will start the program to automatically map the environment. So basically, I have this hacked version of a wall follower, which was a part of the presentation of. It was one of my earlier presentations for ROS Basics.
Yeah. Yeah.
So I basically tweaked it a little bit to make hacky version of the same wall follower to map the
Uh,
arena and
oh, that's
not use the
interesting.
joystick.
Nice.
So I'm gonna call that so ROS launch my Turtlebot navigation start mapping. All right, so let's just see from where it starts. It's a few centimeters before the pedestrian crossing. So let's just make note of that.
Uh huh.
And on this place, you can see
We can see the map.
how it,
Yeah, being created.
yeah. So let's just adjust the size.
That's really
Oh,
clever that you
no,
did that for also mapping.
no, it's,
Question: do you also use it for localization? Because you technically could.
no, I don't because it is just a simple wall follower program. So it's not going to stop at certain spots. So I'm going to use a teleop program for localization. So let's just move this a little bit down. Okay, that doesn't seem to work. That does not seem to work.
I mean, but that looks like a pretty good map already.
Yeah, let's just decrease the size further. So 6. Yeah, that should be fine. So you can actually see the uh, full map, if not 100%. So
Uh huh.
still okay. We have this loaded over here. So let's just bring it down a little. So and minus 0.2 perhaps. That didn't work. So I got to move the x. So and 0. That moves it up. And minus 0.2. That
Can you
didn't work.
explain what you're doing?
I'm just positioning the arena in my arbors. So
Right. So
let's
you're
just put
centering the camera
0.2.
basically.
Yeah, I don't have a mouse, so I can't use the mouse wheel. So I gotta use this way to get that
Oh,
thing set up. So that's why I'm trying to do.
yeah.
So
This in
minus zero
gazebo
point
is a
3.
pain without a mouse.
I have no idea where I'm making the change. Okay, there we go. So it's only 0.3. Ah, okay. So let's change it once again. 0.5. Okay, that's sufficiently inside the screen.
That's good enough. Yeah.
So right around here, the wall follower is going to stop, and the lap is going to be completed. And once the lap is complete, you can already see that the map is already complete.
Uh huh.
So on your screen now, you can see the lap is complete. It's not exactly the spot where the robot started, but more, it's sufficient for us because we're just going to do a mapping, and
Yeah.
we don't really care where it starts and where it ends. So once the mapping is complete, the map is saved, and the Slam G mapping node is automatically shut down. So if you go look at the nav terminal, it is already shut down. We don't have to shut it down ourselves
Oh, and the map is already
because
saved.
yeah, the map is already saved.
Oh, nice.
So now the next thing would be to call localization. So we just call localization tab, launch localization. All right, so I got to give you a heads up. This is going to take a while because I need the error messages coming up. There'll be some warnings coming up, and after then only you will see the laser on Arbus
Mm-hmm.
moving. So you want to wait for that. So
Yeah, yeah. Don't worry.
until that starts, before it starts, we'll just get prepared with our other stuff. So we're
Yeah,
going
and
to
you can just.
start localization. We don't start this yet. We're just going to have it prepared, and we're going to use the teleop. So ROS launch uh, turtle turtlebot 3 teleop that tab. Wait for the model to pop up.
Wait. So then you have two localization launchers. One that's init and one that's start. What's the difference?
Yes. So the init actually launches the ROS navigation nodes, while the start actually does my program, calls my program. So I gave it the same name because one is actually followed by the other. So
Okay, and what do you mean the ROS navigation nodes? Which nodes?
this one will start map server and AMCL along
Okay.
together.
Okay, yeah, that's why I was. So technically, they're not navigation nodes. They're technically separate from move base, I believe.
Yeah, they don't use move base as of yet. It's just yeah. Now we see this all these errors. So I'm not sure why they come up, but only when they come up, I can actually do some stuff on my robot and move it around on Arvis. So I
Right.
just have to wait.
Okay, so it says couldn't determine robot's post associated
So
with laser scan. I
yeah,
believe that's
so
a
it's
connection
gonna
issue.
work.
Yeah, yeah.
It's gonna work. It's gonna work. But we got to do some finagling to get that thing working.
Yeah,
So
usually
now we should
TFs
start the
do this.
localization. Mhm. So we'll start localization. I have a program in this part where I do automatically localize the robot. It works in the simulation, but doesn't work in the real robot. So I've tried it a few times, and I got to do some finagling. So let's just
Mm.
call that and see how it works. So I've just called global localization, and you can see all those red dots on all over the map. Now it's recording odometry for 5 seconds. So
What
it's
are
just going to take
those
the
red dots?
so it's basically the pose array of all the particles that are present in the AMCL uh, adaptive Monte Carlo localization particle filter.
Uh huh.
So, so once the odometry recording is complete for 5 seconds, I average those values and write those values to initial pose, and then I send it to the initial pose topic, and then it localizes the robot somewhere over here.
That's really
But as you
clever.
can see, this works in simulation, but does not work in real robot. So we got to do some finagling around. So and that would be
So,
actually choosing the 2D pose estimate over here and then
okay.
manually doing that again. So we know the robot is somewhere in the middle. So we got to point it this way. So it's going to do that relocalization.
Uh huh.
And now we can see that the robot has moved on RS. And now this is when we launch the teleop. And then we
Yes.
got to do some movement. Because if you noticed earlier, when the auto localization completed, there was a drift in the laser scan. It did not actually coincide well with the map that we just created. So we got to do this. We got to do this workaround to get that thing working.
Yeah.
So now that our teleoperation is loaded, we got to move the robot a little bit front and back.
I've actually noted that the fastest way for the AMCL particles to converge is to rotate it.
Yes, I've tried that one too, but the problem is a lot of particles gets spewed around in front of the robot, so
Right.
uh, the the robot doesn't actually localize properly when you do that. So uh, I've resorted to moving front and back a little bit.
Right. Another culprit is the symmetry of this map. So
Yep.
that is also hurting the ability of localization to work as well as it could.
So now, as you can see, we have our laser scan properly coinciding with the map, and
Yeah.
the robot is at the position where we want it to be, and the localization is almost complete with just a few arrows for the pose array right in front of the robot and heading the direction the robot is.
Uh huh.
So now we can start our program to save the location. So since we are already right in front of the pedestrian, we'll just move a little bit closer to the pedestrian crossing, I mean, and then we'll stop right there. And then this program actually takes the label from the user and then saves that label as a spot. So we're going to call this spot as pedestrian. So say the spot is pedestrian, and then wait for it to save.
Okay, and I see that it's
All right.
taking the positions there.
So we see that the spot is added to the list,
Uh-huh.
and pedestrian is saved as X, Y, Z, and quaternions, whatever values these are. So next we go to the another point. So we just navigate, drive towards another point. So I'm going to call this point corner 4. I'll explain why I'm calling this point corner 4 later. So we'll just stop right here. And then to be on the safe side, let's just stop on the white center line.
As
Because if you
opposed to
don't,
closer to the wall?
yeah, if you move too close to the wall, the problem is the recoveries kick in, recovery methods kick in, and the robots sometimes go into endless rotation.
Yeah.
So we want to be safe with that. So we don't want to go too close to the obstacles.
And
So this is a good spot.
would you take a guess on why that is?
If you actually land the robot in the inflation zone,
Exactly.
that is,
Yes.
so if you land the robot exactly on the inflation zone, overlapping the inflation zone, the robot will start spinning.
Mm-hmm. Yep.
So you just don't want to have any too big of an inflation in the move base part. that is when you're navigating, and have the robot landing on the inflation part.
Mm-hmm.
So that's going to cause you problems. So now this is a safe spot, so we will call this corner 4. And once we save this spot, all right, the spot is saved. We'll move to another spot. So turn around, stop right there. We keep moving front. This spot is perfect for us. Just turn a little bit because that's the way we are moving. So turn around and then note the spot. So this corner 2.
So you're gonna do like a lap with navigation goals or something.
Yeah, I'm just gonna record 5 spots, the 4 corners and the pedestrian.
Uh-huh.
So we're gonna go.
Okay, okay.
So we're just gonna go to the next spot, which is this corner on the bottom right, on the second camera, which is the bottom left on the first camera. So we're gonna move there.
Just to let you know, Girish, we have 10
Yes.
minutes left for the robot reservation. So, in case,
Uh-oh.
so you can
Okay.
man, if we get really like 2 minutes away, let me know and I'll run and extend it for you. But I think you can finish the whole thing, at least like in the robot.
Yeah, let me just map 2 more points and I'll be done. So let's just map this point. This is gonna be corner 3. And that's gonna save it. So let's just start moving. And just keep moving. After this is a good spot for corner 1. So we save this as corner 1. All right, so we have covered all our spots. So now we are just going to end it. So we specifically type END all caps here to end the
Mm.
program. So
And that writes out the YALM file.
yes, so that writes out the YAML file, not the YAML file. It actually writes a text file,
Oh, okay. Sorry.
and yeah, it just shuts down every other node. That is the save spot node, the auto localized node, and the 3 other nodes. That is the AMCL map server and the AMCL and the map server.
Oh,
Just
nice.
the 2.
So you have a
So
whole
once the map server
integrated
is killed,
system here.
yeah, pretty much, yeah. So now if you go check this one, this terminal is done. So the nav section for localization is now complete.
Mm.
So next we got to call the navigation, which is the final part. So navigation, we launch this one, and we'll be doing the same stuff over here again. So we got to do that. What is it? The localization finagling, what I mentioned to you earlier. So
But
we just need to wait for the all the sensors to start up. So start navigation, and we got to wait there and have the teleop ready again. So yeah, it's fine. Let's just be loaded. Yes, you were about to ask me something.
yes. Well, all right. Yeah, I see why that's happening. Why you're having to localize twice is because you killed it with your end.
Exactly. Yep.
Okay. Okay. I see.
So this nav node will actually start map server, AMCL, and move base. So the first
Okay.
one just started G mapping. The second one will start the map server and the AMCL, and this one will start a map server, AMCL, and move base.
Right.
So yeah,
Okay.
we just need to wait for the error to pop up again. The error that said could not localize because of laser scan something blah blah. So we just need to wait for that error to pop up again.
Okay.
In the meantime, you can try doing this to the pose estimate. It's not going to work, but you can just make sure that the RVIS has something moving. If nothing moves in ours, means okay. There we go.
Oh,
So
now it
something happened on
moves.
ours, and that triggered this robot's post associated with laser scan error. So yeah, now we just need to wait for the global cost map to come in and the local cost map to kick in. All right, so global is uh, done. Nope, the map is loaded. The global map is not yet loaded.
By the way, I just extended your reservation, so hopefully it'll
Oh,
keep
thank you.
going. But maybe you'll have to refresh or something. But we got 25 more minutes. That's okay.
All right, I should be able to complete before that. Hopefully, we are in the last section. So yeah, we
Uh
got
huh.
the global planner set up, the global planner cost map up. We just need to wait for the local cost map. So we'll probably do another 2D pose estimate again. Oh, local cost map is loaded.
Yeah, I can
All right,
see
since we clicked on it, we'll just do that.
some purple.
So this is where I need to wait a little longer because the local cost map loads, and then we need to wait for the recovery server actions to kick in. So that's going to take a while, and then we need to wait for the ODOM data to come in. So once the ODOM is ready, we'll see the local cost map around the robot, and then we are good to move. So we
Oh.
need to wait until that part.
And let me ask you, Girish, this happens
Yes.
in the simulation or just in the real robot? This
No,
waiting
this
time.
does not happen. This does not happen in simulation. Everything is perfect point to point, like exact on the time.
Hmm.
This happens only with the real robot.
I see. Uh,
I don't know why. Probably you could explain it to me later, but
well, there's two
let's just concentrate
options.
on finishing this process.
It's either the
All
ROS
right.
checked or the robot. So I have to take a look
Mm-hmm.
because I mean, if it was the robot, then probably you
Mm-hmm.
wouldn't be able to navigate because if the autumn is taking so long to come in or something, when you launch a goal, it would get
Mm-hmm.
lost. You know, it would take a
True.
long time to get a new odometry reading, so it wouldn't ever do that. So I'm guessing it has to be a connection thing. So, uh, but um, I appreciate you telling me these things, and thank you for putting up with it. But you can see,
All right. So we see something is still happening. So we still need to wait for the recovery server to kick in. So far we have
so
the local cost map has started.
this is to avoid setting the pose yourself, right? This whole
Yeah.
process. Okay, because I have a point on that. While this is loading,
Mm-hmm.
let me talk about it. Because I mentioned it.
Sure.
I mentioned why
All
don't you
right. There we
use
go. We have
okay,
recovery behavior.
keep going, keep
So we got to wait one more of this, yeah, message, and then ODOM will kick in. It takes us a few seconds longer, so you can go ahead. You can tell me whatever
going.
you need to
Right.
tell me. Sorry to
So
sorry to
I,
bother you.
and this I'm just improvising here because of this. But
Mm-hmm.
let me tell you that that's why I asked why you don't why you shouldn't why if you used that service I'm sorry service that script to go around the wall and map, why don't you use it to
Mm-hmm.
localize? And I couldn't really understand your point.
All right, there we go.
Oh, the autumn
We got
received.
we rece- we got the ODOM. Yep, we got the ODOM right here. So now we can start doing our stuff. So we can start the navigation, which is the last part. And this file actually works. I mean, has the procedure to move the robot to whichever location you want based on the locations that you've saved before.
Mm.
So now you're going to see the auto localize service working again. And once it is complete, we got to do that localization finagling again. So please be patient.
All right. Okay. Well, this goes exactly into my point then. It looks like
Hmm.
the bottleneck here is the localizing, and
Hmm.
you're doing a script to go around it, which is
Hmm.
great. But there's other ways to do this, and that's why I talked about that script to just move around. So I'm assuming
Hmm.
right there you
Hmm.
use the service spread particles or something, right?
No, global localization. That's right there.
Okay, well
This is the
there's a
service name.
service where you reset
Hmm.
the particles randomly across the map,
That is
right?
true.
And as long as the
Yes.
robot moves, it's auto localizing. So for example, if you have a robot that
Hmm.
has to go charge and it uses an AR tag or something to publish a
Mm-hmm.
frame. Well,
Mm-hmm.
what I would do is just move it randomly, move the robot randomly, and just assume that in 5 minutes or so, it's going to be well enough localized. So when you launch navigation, it'll do fine. For example, sometimes you don't even need to localize it
Mm-hmm.
if the map is very asymmetric, and you'll see all the particles spread out. And as you launch
Mm-hmm.
the goal, you'll see in the beginning it doesn't know where it's at because it's not localized. But since it's moving, it'll continuously improve. So um, maybe that's something to look at to kind of streamline. But at the same time, I love that you did that to auto localize, and it works well in the simulation, and it works,
Yeah.
which I want to ask you more about it, but we'll
So
wait for this.
we just did that finagling again. So we just did the 2D pose estimate on Arvis again to to bring the robot to the point, and now we got to do the teleop again to just move a little bit so that we have a robot position in position.
Right. This is what I'm saying. You can avoid. You can just click once and avoid it, this whole uh,
Hmm.
pipeline. But
But I also believe that the problem is because I'm actually closing the nodes in the from the previous execution.
yes,
So
that's another thing. Yeah.
if I had the nodes running, I could probably do what you're saying. But since I'm closing for this
Right.
specific project, it's probably not working.
Is there a
So
reason why you do that, or did we tell you to do that, or?
no, it's just something I implemented, and I'm not really sure why I did that. So I'm
Well,
just
cause no,
maintaining,
but this is
going
good
with
because
that.
you keep it organized in your head, and that was great
Hmm.
that you save the spots and then you could press end, and that kills localization. That shows that you have a sort of a
Well,
walkthrough of your
well, the main
process.
motive is the main motive behind is that you already have the saved locations,
Yeah,
and you need to go to the spot. So what if you turn off the robot and you need to start all over again? You don't want to map again and then save the
exactly.
spots and then go to the point, right? So this way, since you already have those things saved, you can just call the localization and do some localization, some global localization, and then move to those spots. So it's like shutting down your robot and then coming back online and then not wasting time on mapping the area again.
Oh yeah, I know map once, and sometimes even the simulation map will work for the real one if you did a good job with the simulation. So yeah, you
Hmm.
only need to map once, and so one thing I do
All
when I
right.
work with robots is I never
Hmm.
kill localization. I just let it
Got it.
do its thing forever.
Understood. All right. So all right. So let's just move back. Yeah, we have already localized uh, almost fine. So we'll just come back
Like
a little
you
bit.
said, almost fine. I guarantee you that it will work because it's close enough that it. So I mean, the beginning it might move a little bit wonky, but
Hmm.
you're fine now. You can send goals
Now you can see that the laser scan is actually in line with the map
lined up. Yeah,
that we have. So you can also see the global map, cost map, and the local cost map. So
yeah.
now we can kill the Turtlebot navigate teleop, and then we can start with the localization. So now we know the point that is lying right in front of us, the pedestrian. So we're just going to call pedestrian. So it's going to look up the pedestrian spot and then navigate to the pedestrian spot. All right, so spot is found in the file, and then we need to wait for the robot to move. As you can see, the goal line is popped. Goal line is right there,
Mm-hmm.
and then we just need to wait for the robot to move. Hopefully, teleop is not stopping the robot. All right, so
Nah,
we got something going on.
I can see it's spinning, so it's probably trying to.
Recover, which is probably a nightmare. I don't want at this point.
Oh, let's see. If not, we can do another spot, or if not, you can send it to. What I'm concerned about is so that local or global cost map. Which is it? Like the purple thing that appears when
Okay,
you
so
launch
the
move base?
mhm.
What's that? Is that the local
So
cost map or the global cost map?
The first one is the global cost map, and the smaller one is the local cost map.
Could you turn off the global one?
Yes. All right. So this is the global cost map. So yeah, let me just turn that off. All right.
Ah, I see. So just FYI, the global cost
Mhm.
map is usually black and white. So you can go into the
Yep. Cost map and
settings.
change it to map.
Right. Yeah.
Hmm.
I mean, it's a preference thing, but
Yeah, we can do that.
I got confused. No, no, no. You don't need to. Just
All right. So we can go to this one. Change to map. All right. There we go. Is this the one?
yeah, perfect. So now you can see. Okay. Yeah, yeah. All right. I don't think
All
it's
right.
gonna get
So
there, but I think it's because it's a weird point.
yeah, you got to probably localize again.
No, no, don't.
This one
Oh, I see. It got. Why did the
because
particles?
it got delocalized.
Why?
Yeah, because the recovery server kicked in and then the points just went half a side.
Oh, so
And then
navigation relocalizes even though it shouldn't.
mhm,
Uh,
when it starts spinning, it goes back. Oh, we got to
Before
wait
you
for
do
a
the
fix.
spot, I want you to try something.
Sure.
Once this is fine
Just a moment.
already.
We'll just localize.
Yeah,
Yeah,
like
we'll just localize a little.
is so I'm assuming move base is working right now because I see the local cost map. Just send
Hmm.
a goal with Arvis. Don't do the spots. Let's see if we have a problem with navigation or the spots. So you do like the 2D goalpost, just send it in the middle,
Okay.
like somewhere that it won't. That way I can, check off the fact that, move base works for you.
Oh, so this won't not work. We got to cut this teleop. So Control C, and yeah, now it should start to move. Yep,
All
there we go.
right. Okay. Yeah, this looks better. Okay. So I'm assuming the safe spot is because it's closer to the wall. And
Hmm.
I think uh, you have to find a balance between the inflation layers and where you want to save your spots because maybe your robot radius is a little too big or whatever, so it won't find a path.
There.
But I want to
It's going to one
emphasize
of our paths.
how much this depends on the map. You have a really hard
Hmm.
map here. If you had a big map, this would be super easy. But
True. True.
you have to sort of identify why things happen because of move base and why things because of the nature or the environment you're doing it. So let's see, corner 3.
We just stopped at corner two. We'll be going to corner three now. There we can see the
Yeah,
goalpost, this orange line, and robot is now going to the goalpost.
but see that looks like it's really close to the wall. The goal, unless I'm
Yeah.
not seeing. Yeah, so it probably won't get there, and we'll see that in the terminal. We'll see like it's
Hmm.
attempting to reach blah blah blah.
Well, this is not going to say anything, but we can just check out this nav uh,
Oh, the other one. Yeah, yeah. This
terminal.
is yeah. Okay, I thought you had that off map. I've never seen that.
To be honest, I still have no clue what off map and those two coordinates actually give me any info on. But yeah, I'm just gonna make peace with it for the moment.
Yeah, and I have
All right.
some theories. But all
All right. So we
right.
have reached the goal.
Yeah,
All
we.
right. So next we go to corner one, which is the initial spot, which is the V-construct decal zone.
Uh huh.
That is right here. So hopefully it doesn't tip off any blocks.
It shouldn't if your local cost map is set correctly.
Yeah, this is something that I've noticed. Like, so I mean, while it's moving, it stops
It
in the middle
stops.
for a while, and then it continues. I don't know
This
why.
might be a processing speed thing. Uh,
Yeah, now it's done.
right. All right.
Apparently, it's not the spot that we saved, but because our localization
Because
is
of
not
localization,
so
but
good,
it's good enough. Yeah. And you
it's
should
close
never
to what we
do
have.
you should never use navigation like this for precise stuff, right? For example,
Mm-hmm.
if you want to charge, uh, you should use something else. You maybe can approach it with this and face your charger, and then you do something else, with the
We can
laser or
probably do something
cameras.
like geofencing where we can use this kind of a navigation and then go near the spot and then use some complex algorithm when you're close to the spot and then go to the charger correctly.
I don't even. Yeah, well, it's even easier than that. All you do is just like a simple PD
Mm-hmm.
a controller, and you
Mm-hmm.
can be looking, for example, at the two distances of your robot. Maybe you want them to be equal, and that means it's facing the charger. Or you have a TF that you published because you have a camera and you can see an AR. There's many ways, but
Mm-hmm.
the thing is, you
Mm-hmm.
shouldn't use navigation because it's not gonna get there precisely. You need
True, true.
precise movements. All
All
right.
right, so we are done. So we have reached the spot, and the pedestrian point is apparently matching with what we have recorded before. So
Yeah.
we don't have any problems with that. And just to be just to show how safe my server is, if you try to put in some value that is not in the file, for example, you can see centered over here. This is a hard-coded string, by the way. So
Uh huh.
we didn't save a center spot. So when you put in center, it's going to say the spot is not found in the file. It's going to look up and then it's just going to say spot is not found in the file. So that's it. We are done. So we'll just terminate, all caps end, and then we'll just wait for everything to close.
Awesome. This is really, really good.
So look, load spot is shut down. We got auto localized server shut down, and then we got yeah, both of those nodes shut down, and then move base is killed, followed by AMCL and map server.
All
So we
right.
just need to
Yeah.
wait for those AMCL and map server.
Great. This is my favorite
All
part.
right,
That
this one is terminated, and Napstack is also terminated. Where is it? End. There we go. This is terminated.
great.
All right, so we have finished our presentation.
Awesome. Let
So
me.
let's, yeah,
I
go
got
ahead.
many questions for you. Well, not questions, but like comments to talk about this. And first of all,
Mm-hmm.
as always, a pleasure to look at your projects because they are very
Thank you.
organized, and it looks like you have spent a lot of time here trying to think of what the clearest way to show your work is, and it
Mm-hmm. Mm-hmm.
shows. It's first, so congratulations on that. And
Thank you.
so another thing that I
Mm-hmm.
really liked is that you followed this sort of story of your project in
Mm-hmm.
where most things were interlinked. So for that thing that I told you, oh, you found a way. You made a script to localize itself. You made a
Mm-hmm.
script that when you save the spots, then you kill localization. That helps you a lot to put yourself sort of in the um, mindset of what you need for the navigation. And for things like this,
True, true.
when it's not really that much about coding as it is of like, I think about navigation, move it, all these packages, great packages that are the strengths of ROS, which is you can just use
Mm-hmm.
it and adapt it. I think about it as a puzzle, right? Of putting
Mm-hmm.
things
True,
together
true.
in order to work. And
Yeah.
I think this process that you're doing really, really helps in that. So that's a good comment. That's a great thing that you do. But then again, it can lead to things that, for example, localizing that much or launching localization
Mm-hmm.
7 times, or you can only do it once. But this is just like a personal thing, That's just how you work better
True,
and
true, true.
understand things.
Yep.
But you have to think it in a way that the robot will do it every time, and uh, it won't kill nodes accidentally, things like that. Because
True.
when you have 30 nodes running and one of them dies, and it takes a long time to figure it out. So
Yeah, apparently running multiple nodes in ROS 1 is easy as compared to ROS 2 because we can only specify up to like 8 nodes running per launch file, I believe, like to like the number of cores in your CPU. So So ROS1 seems to be helpful in this case, like launch multiple nodes as opposed to ROS2, but I might be wrong. I haven't tried this one on ROS2 yet.
Well, I haven't put more than 8 nodes in a launch file. I don't think. Maybe I have, but not usually. But I have systems
Just
that.
off topic, I did put more than 8 nodes in one file when I did when I learned ROS2 navigation course for the multi multi, what is it, multi robot simulation.
Uh huh.
So when I put like about 12 nodes in one single launch
Yeah.
file, it got super stuck. So yeah, I had to separate them.
Yeah.
So yeah, that is probably where I find the node limits, like the node count limit.
Right.
This is
Okay.
with ROS2 though, not for ROS1. So let's start with my presentation.
Yeah.
So yeah, this project implements ROS navigation stack to a real robot to perform robot navigation using the knowledge that I've gained from ROS navigation course. Sorry for the ROS2. All right. So yeah, just ignore that. It's
Don't worry.
ROS navigation course. With this implementation, the robot will have the ability to generate a map of the environment, localize itself, perform path planning from point A to point B, and then navigate itself within the environment. So this is the ROS navigation stack. It is actually a framework which provides tools to make a robot navigate within an environment. It takes sensor measurements like orometry and laser scanner or point cloud as inputs and provides speed-controlled actuator outputs to move the robot from one point to another point, basically from start to a goal point. And for mapping, we use a gmapping package. For localization, we use AMCL, which is adaptive Monte Carlo localization. And then for path planning, we use the move-based node. We have 4 parts for this project, which and they are mapping, localization, path planning, and the navigation. So mapping has the mapping part is where you create the map of the environment using the ROS nav stack with the gmapping package. You basically launch the gmapping node, move the robot around, save the map, and use the saved map for localization and navigation. In the localization phase, you localize the robot on the saved map using the AMCL package of ROS navigation stack. So you launch the map server node and with the saved map, launch the AMCL node, move the robot around to localize the robot, and then you have a service to save the locations on the robot on the map for the robot, and then I have an additional service to automatically localize the robot on the map once the AMCL package node is started. The third part is path planning, where we create a path planning system using the move-based package of ROS navigation stack. So this basically launches the map server node and the AMCL node with the saved map, and then creates necessary and we create necessary configurations for the files for the path planning to work. So we work with the cost map generation files, global path planning files, and local path planning config files, and then we make path planning work with the move-based node. And then we finally launch a move-based node for this part. And finally, we have the navigation part where we apply all the 3 packages that we saw earlier with the ROS navigation stack to perform the robot navigation. And we create a service to load the saved locations on the map, and we have an action client that sends the saved locations as goal poses to the robot using the move-based action server. And then we launch the map server, AMCL, and the move-based nodes together, and then we navigate to the saved locations on the map when we send the post to the move-based action server. So as we saw in the presentation earlier, I had 3 parts: the mapping, the localization, and navigation. Mapping calls the slam gmapping node and then runs the wall follower program to simultaneously localize and map the arena automatically. The localization part is where it runs the map server and AMCL nodes and moves around the robot and then saves some location on the map to navigate. And as you can see in this diagram, this is how I've named my corners. So the construct decal spot is corner 1. The point directly opposite to the corner is corner 2, and then corner 3 is right opposite to the path to between corner 1 and corner 2 on the top right, and then the corner 4 is the opposite direction, followed by the pedestrian, which is right in front of the pedestrian crossing. And the third part is navigation, which combines path planning and the movement. So it runs the map server, AMCL, and the move-based nodes to navigate the robot to the saved locations on the map. So I use two custom messages in my entire packages. So one is called load spot, the other is called save spot. So load spot is a service message to load the spot from the file, and save spot is a service message to save the spot to the file. And both of them are basically the same except for this one single part, which is spot loaded and the spot saved. So you basically send a label as a string, and then it gives you the response. The bool is basically true or false, which gives you a spot is there or not, saved or not, and then the message that whether it's successfully saved or not. And the auto localized service that I'm using,
Uh,
I tried using empty and trigger, and it did not work for the first time because I wanted to localize it, but then later on I wanted to also kill it. So if I use empty, I wouldn't succeed in killing it. So I tried to use trigger, but again I couldn't kill it because the request contained nothing. So what would I send to kill it? So that's why I went ahead and used set bool. So when I send true, it'll start the localize, and when I set it to false, it'll just kill the auto localized server. In all the,
okay.
in all the cases, yeah, I'll get a success message and a message, string message that said if it's successfully done or not.
Okay.
So the mapping, this part starts slam G mapping as I told you earlier. The only tricky part, I mean, the only nuance that I had in my project is setting the delta parameter to 0.010, that is like 1 centimeter map resolution. And then I used a wall follower program, which is a very hacky version. So what it does, it starts at the point, follows the wall on its right. The algorithm is not discussed in this presentation because it's out of topic. So we don't need that discussed over here. So, and it ends roughly at the same start spot. It saves the map at the end of the lab. It shuts down the slam G mapping node and terminates the wall follower program. So as you saw earlier, it starts from a point where there's no complete mapping, then it moves around, goes around, and then the entire mapping is complete. The next part is localization. So I start a map server, and it provides a saved map, and start the AMCL with about 250 to 2,500 particles. And then I call the auto localized server. So when the data is sent, when the data sent is true, it calls global localization. It records the odometry for 5 seconds and then sends it to the initial pose to set the to localize the robot on the map. Unfortunately, this did not happen in the real robot case, but this happens for sure in simulation. And when I set it to false, when I send a message with false, it basically shuts down the server. So auto localizes node gets shut down. The other server is a safe spot. So basically, when I send a label that is not end, it
Mm-hmm.
saves the spot it saves the robot pose into a list, and then if I send end, it just saves the entire list into a text file and then shuts down the server. If I send nothing, the pose is not saved, so it just sends you invalid pose or pose cannot be recorded. And then the client for the save spot is basically starts with auto localizing the robot on the map. And if it's not end, it just sends the label and gets the robot pose. If it is end, it sends the label, shuts down the nodes, and then terminates the program, which is save spot service client. So this is what happens. It initially starts with some random AMCL startup, and then we do global localization to send all the pose array points, arrows into all over
Yeah.
the map, and then it gets to the point once the localization is complete. And then once we choose a desired spot, we'll see all those arrows coming up in front of us. Like I have no idea about the count, but it's something between the count is somewhere between 250 and 2,500 for sure.
And I'm sure you can configure that somehow in the
Mhm.
AMCL.
The next part is navigation. So we start the map server along with the AMCL node, and we also start the move base package with nav function ROS as the global path planner and DWA planner ROS as the local path planner. And then we have the load spot service server, which basically uh, sends the label to the server, and then if it's not end, it basically returns the robot pose that is from the saved text file. And then if it is end, it just shuts down the server. And then we have a client for that. So no, we have an action client. So the action client runs the auto localized service first, and then it starts the load spot service client, and we call the move based action. We start the move based action client, and within the client we get the label from the user, and then we check it with the load spot service client. And if the label is present in the text file, we basically send the label to the load spot service server, and we get the pose from the text file if it is present, and then we send that pose to the move based action server as a goal, and then we wait for the robot to reach the goal pose. And if the label is end, we just shut down all the services, nodes, and we just terminate this navigation program. And that's pretty much the part. I mean, all the sections. So we start with random localization, and then we do global localization to spread all the particles all over the map, and then we localize the robot, and then we give it a goal post, so you can see the green line, and then the
Yeah.
final goal post that we have set, and then the robot moves there with the trail of white dots, if you can see, and then it just goes and settles there once the goal is reached. So that is navigation,
Amazing.
and that would be all the parts. So this is what I think would be the areas to improve. So I should probably make a finer map with better resolution when it comes to smaller environments, and have a better method to localize within the environment without having any drifts with the robot, and provide some navigation statistics like distance, speed, and time when I move to the goalpost from any spot. Add perhaps collision detection and collision recovery methods, so that we don't have to necessarily barge into the robotic system and then pull it down or do something of the sort. The robot will just escape itself.
Mm-hmm.
This doesn't actually coincide well with the recovery methods. So if the robot collides and the recovery server kicks in, and if the recovery is spinning, and if the robot's wheel is probably uh, is in between an obstacle where it has bumped ahead, and the robot is not going to spin. So in this case, we need to have a better recovery method.
Yeah.
According to ROS, the problem is you can choose between spin or move back a little, but you cannot have both of them running. So we need to come with
Oh,
a better
really?
plan to, yeah.
Well, Rust 2,
So
you're
only
able
one of
to.
them, yeah. In ROS 2, you can actually sequence your actions. So
Yeah.
you can choose between rotation, go back, and then probably wait over there
They're
and
not
so.
very good, to be
But
honest. Like
yeah,
the
but
default
in
ones.
in case of ROS, you need to have some collision detection and recovery methods. So
Mm-hmm.
yeah, let's just say your wheel is stuck at probably some stone on the floor, and then if your robot goes into rotational recovery mode, the robot is never going to spin, practically speaking.
Yeah.
So it will just assume that it's spinning, but it's not going to spin. So
And
in
it's
that case, what can be done?
and everything
So
else will get screwed up because if it's stuck with a what is it, with a stone or
exactly,
something, the odometry is
yeah.
gonna think it's going forward. So you'll see in our vis how it's doing that when in reality it's not. So everything gets out of whack. Yeah.
Exactly. And the final part that I would like to add is have a image processing based pattern matching and correction algorithm to overcome drifts in the laser scanner when the localization is not 100% successful with the AMCL node. We
Yeah.
already saw this in our running in our presentation. Like when I did the global localization and then automatically localized the robot, the laser scanners were not exactly coinciding with the map. It was far away by a few centimeters.
Yeah.
So the method should have worked, but it did not work. So we need to find a better method to make it work better.
Better.
So this would be one of my improvements areas to consider,
All right. Yeah. Well.
and that
Yeah.
would all be all my presentation.
Great. Great. Thank you, Girish. Let me just mention a couple of things before we leave off.
Hmm.
Uh, yes, you're right. There's always ways to do better localization. However, I
Hmm.
think personally, because I'm not like really into better localization systems because what I have already works for me. Um, basically, what I want to say basically is to not worry that much about localization, you know? Because let me tell you what I do when I use robots. I have robots here and they have to go charge on something. I just make them move for a
True.
little bit. I make them rotate. I do the global localization so it spreads the particles
Hmm.
and I just move it. And uh, uh, for 2 minutes, rotate both ways, go back and forth in a little bit, even if it's not very
So
well localized.
I have a question for you. What if the battery is like critical stage, and when you do the localization thing, the robot actually fails,
Well,
like
it won't
power
because I
goes up.
tell it like a 20%, not a 10. So I'll know it'll still go for
Got
like
it.
1 more hour, But yes, you're right.
Got
If
it.
that has that drawback, every one of those
Hmm.
has a drawback. Or the other one is, just send it to a place that you're recognizing with the intensity of the laser or something and use the
Hmm.
localization there. Um, the reason why I say that is because of how troublesome, I guess, and how little I actually think about localization when I'm doing it. That's why I'm saying I just leave it running. And what I kill
Hmm.
and restart is navigation. So
Hmm.
I understand that you did what you did for your project, and
Hmm.
so it's self-contained. So you can launch the navigation part and everything will work. Launch the localization part, everything will work up until there. But in for practice, for example, I would have maybe, I don't know if I would avoid it, honestly. Maybe your way is actually better, but let me tell you something that can happen. For example, the map server only needs to be launched once, right?
Hmm.
You launch it once and
True.
it's like living in the ROS core or wherever because you
Yep.
can open RViz and
Hmm.
look at it. And you're like launching every time. You know, I don't know if you do that repetitively. I don't know if that will.
No, I was just considering a real-time case where I map my area today. I do the save
Okay.
spots tomorrow, and then do the navigation probably 5 days later.
Okay. And let me tell you,
So in
let me
that case,
ask
I
you,
need to have a good
i-
system.
right, right. And do you make, did I understand right that you make the map every time you wanted to navigate? So did you make like a
Uh,
hundred maps basically?
yeah, since in my last few attempts, I basically did the map and then navigated because if I can save the map in my simulation. It does not have, I don't have any problems with that.
Yeah, yeah.
But when it comes to the real mapping situation, one time my map comes like this, the second time my map gets like this. So when localize my robot in that environment, the robot is probably thinking I need to go
Oh.
this way, but instead it's going this way.
You mean the
It has
orientation
to
of
go
the map?
the map. Yes,
You know
yes.
what that depends on? Where you start mapping, I
Hmm.
think.
Yeah, I figured that out. But the problem was when the map gets saved and it gets relaunched, it does not the localization does not happen properly. So it's
Ah,
like I have a map like this, and the laser is gonna output something like this, but instead it comes like this.
I understand. Yeah.
So there is no way I can localize the robot again with this configuration. So that's why I decided to do mapping and then localization and then what is this
I understand.
navigation.
Like a foolproof way. Yes,
Hmm.
that's good. Yeah.
Because when I tried it on real robot, one day the obstacles are on one spot and some other
Yeah,
day it
that's true
gets
too.
strewn around.
But for example,
So
I do sometimes overdo the like as long as I have one defining feature of my map, I
mhm.
take away things on like chairs, things like that, and I just hope it works. But you're right. You're right. That will mean that you get every change in the map that is, and especially in a square like this, it'll get lost. And I think that what you
True.
were talking about, a lot of it is because of the map is very symmetric, and that's maybe why it happens. And
Mhm.
we'll have to see how much is that, and how much is like the auto localization, things like that. But
I also
overall,
noticed odometry based drifts. So
right.
if I start at one point and if I start at the same point again, the point is not the same.
Exactly. Okay. All right. Well, I think this will cover. It's a really good presentation, and
Thank you so much.
thank you so much, Girish. And again, really, really good job. 10 out of 10.
Just want to say another thing. I specifically didn't want to show my code because of yeah being private. So
Oh yeah, don't
yeah,
worry.
please don't viewers, please don't mistake me for not showing the code.
No, no, I believe you. I mean, and it would have been way too long if you showed the code
True,
because
true.
we want to think about the like the puzzle, right? I don't really
Hmm.
want to look at your pie. I just want to see that it works. So
Yeah, true.
um, great, great. Well, thank you, Girish. And for everyone else,
Sure.
here's a perfect project for navigation. So if you want to come in and do your presentation with us to get a certificate, I recommend you take a look at this video. So
Yep, definitely.
uh, thank you again, Girish, and hope to see you again soon. And Thank you
Thanks
for
for
all
having
that
me.
you
Yeah,
do here
I'll
at the
be coming back
construct.
for ROS 2 navigation,
Great, great, great. We'll see you around then.
probably next week. Yeah.
Okay. All right. Well, bye bye,
I'm done
everyone.
with the project already. I just need to do the presentation.
All right. Good, good. All right, on. Okay.
All right. See you all. Bye.
Bye bye, everyone. We'll see you for next presentation. Bye bye, Girish.
Mhm.